Yeah, hello dear students. You are welcome to session 7 of core mathematics for senior high school. So we'll be looking at linear equation under this lesson. Okay, so if you are ready, I'm also ready. Shall we begin? Alright, so let's look at the outline for this lesson. So by the end of this lesson, you should be able to solve a simple linear equation. Alright, so solve linear equations in one variable, and then you should also demonstrate skill at solving word problems involving linear equations in one variable. Alright, so these are the two main objectives that you are to achieve by the end of the lesson. Alright, okay, so let's now begin. Okay, so what is an equation? So briefly, we say that an equation is a mathematical statement in which two expressions represent the same quantity. Alright, so basically you'll be given two different expressions. So you have one expression on the left side and then another expression on the right hand side. Alright, and the two expressions are separated by an equal to sign. Right, so the equal to sign just tells us that the expression on the left is the same as the expression on the right. So here we are having 3x plus 4 is equal to 25. So what this means is that the value of 3x plus 4 must be the same as 25. Right, now you realize that we are having a variable x here, right? So there is a letter, right? So basically in equations we use letters to represent any unknown value or an unknown quantity, right? So the intent or the purpose of solving an equation is to find the value of that unknown quantity, of which we have represented with the variable or the letter. Right, so here we have 3x plus 4 is equal to 25. So it means that the x here stands for a value, a number, a figure, but then we don't know that figure yet. So in place of that unknown figure or value, we are using the letter x. So the purpose of solving an equation is to find the value of x, which represents a number. Right, so that is basically what equation is about. Right, so we say linear equation because it is like a line, right? So as you can see, 3x plus 4 is equal to 25. So it is linear, right? And under this lesson we'll be looking at linear equation in one variable, meaning that we are only going to see just one letter in a given equation, just one letter, right? So that is basically an overview of linear equation, and this is not a topic in isolation, right? You would apply your knowledge on linear equations on other topics, right? Right, so as you move further, as you study other topics like change of subject, simultaneous equations, and even algebraic expressions, you would come across linear equations, right? So your knowledge on this topic is going to facilitate your understanding on other topics as well, right? So let's proceed. Alright, so we said that the purpose of solving a linear equation is to find the value of an unknown quantity, right, which is represented by a variable. Right, so in doing that we have to take some principles into consideration. Right, so first of all, let me give you this basic rules or guidelines. Right, now because your aim is to find the value of that unknown variable, what you are going to do is that you are going to migrate or move anything that is attached to that variable, you are going to move it to the opposite side of the equation. What I'm saying is that you are going to keep that variable at one side of the equation, right? Because your aim is to find the value of that unknown variable. So here we had 3x plus 4 is equal to 25, right? So in the end we have to get x is equal to a number, x is equal to something, right? So it presupposes that anything that is attached to the x must be moved to the opposite side. So in the end x must stand alone. So that is the purpose of solving an equation. In the end, that variable or that letter must stand at one side of the equation. So you should have x is equal to something, right? So in doing that, it means that we have to move anything that is connected to the variable to the other side, or we have to eliminate it, right? So in eliminating all those things that are connected to the variable, you have to take some rules or guidelines into consideration. Alright, so first of all, you have to expand all terms with brackets. Right, so it could be that that variable is caged within a bracket. Right, so because it is within a bracket, the first thing you have to do is you have to expand that bracket. You have to expand it so that you would set it free, so that it can stand on itself, it can stand on its own. Right, so that is one thing. So let's look at this example here. So here, for instance, we have 2 into bracket 3y minus 2 is equal to y minus 19. So it means you have to find the value of y, right? But because this y, we have y here, which is caged in a bracket. So the first thing we have to do is what? Is to expand this bracket, right? So when you expand this bracket, you are going to have 2 times 3y, which is 6y, and then 2 times negative 2, which is negative 4. So when you expand this bracket, you are going to arrive at 6y minus 4 is equal to y minus 19. Right? So that is the first thing you have to do. Whenever you come across a bracket, you expand it first. Right? Okay, the second thing is that you have to group like terms. You have to group like terms because your aim is to find the value of the variable. As much as possible, you have to make sure that all the variables are grouped at one side, and then all the constant. Now when we say constant means ordinary numbers, right? Ordinary numbers, right? So here we had 2 into bracket 3y minus 2 is equal to y minus 19. So the first thing we did was to expand the bracket. After expanding, we had 6y minus 4 is equal to y minus 19. Now the next thing is to group like terms, right? So we have 6y, we have y. So grouping like terms means that put all the y's at one side, and then put all the ordinary numbers which we term as the constant, put them at another side separately, right? So that is what we have here. So we had 6y minus y, right, is equal to negative 19 plus 4. But let's try to understand why it became 6y minus y is equal to negative 19 plus 4. Let's understand it. So let's look at the next principle. So in grouping like terms, if a positive term crosses the equal sign, it becomes negative and vice versa. So let's look at this same example. So like we said, you have to group like terms, meaning that group all y's at one side and group all constant or all ordinary numbers at another side. Alright, so in moving from one side of the equation to the other, you have to take note of these two principles. When the term you are moving is negative, the moment it crosses the equal to sign, it becomes positive. And when the term is originally positive, when it crosses the equal to sign, it becomes negative at the other side of the equation, right? So here we had y at the right side, so we want to bring the y to the left side. Now what is the operation of the y here? It is positive. So in moving the y from the right to the left, because it is positive, when it crosses over to the left, it becomes negative. That is why you have 6y minus y over here. I believe you are getting it. And then we want to also move this negative 4 to the right side of the equal to sign. Now because it is negative y, because it is negative 4, when it crosses the equal sign to the right, it will become positive 4. That is why you are having negative 19 plus 4, because this negative 4, when it crosses, it becomes plus, so it will come and add up to the negative 19 already here. That is how come you have 6y minus y is equal to negative 19 plus 4. I believe you are following. Now let's look at the next thing to do. So after grouping like terms, the next thing to do is to reduce the coefficient of the variable to 1. So here we are interested in finding the value of y, right? Now when you evaluate 6y minus y, you are going to arrive at 5y is equal to negative 19 plus 4 will give you negative 15, right? So it presupposes that 5y is equal to negative 15, but then you were told, or your aim is to find the value of y, not 5y. So it means that you have to reduce the coefficient. The coefficient of y is 5. When you talk of coefficient is simply the number that is multiplying a particular variable, right? So a term that is multiplying a particular variable. So here, what is multiplying y? It is 5. So 5 becomes the coefficient of y. But then because we are interested in finding the value of only y, our next step is to divide both sides by 5, so that we are going to eliminate the 5 that is attached to the y, so that in the end y will stand alone, right? So what you do is that you divide both sides by 5. So you have 5y divided by 5 is equal to negative 5 divided by 5, right? So the 5 down here will cancel the 5 up here, leaving you with only y, and then you divide the negative 15 by 5, giving you negative 3, right? The reason is that with equation, whatever you do to the left hand side of the equal sign, you do same to the right side of the equal sign. So if we are dividing 5y by 5, it means that we have to do same for the right side. So we have to divide negative 15 also by the 5, right? So in the end, they are going to have y is equal to negative 3. So this means that the unknown value of y has now been found, right? So it means that all this while y was equal to negative 3, but we didn't know until we found it, right? So you can verify your answer to find out whether you are right, right? So it means that when you fix this negative 3 into y, into wherever you see y in this equation, you have to get the same result. That is, the value at the left side must equal to the value at the right side. So let's try it out and see. So if we are to fix negative 3 into y here, okay, so we would have 2 into bracket 3 times negative 3. Now 3 times negative 3 will give you negative 9, right? So you have negative 9 minus 2, giving you negative 11, right? Negative 11. So for the left side, you are going to have 2 times negative 11, and that gives you negative what? Negative 22, right? Now let's see whether the right side will also give us negative 22, right? Because this equal to sign implies that the expression or the value of the expression on the left side must be the same as the expression on the right side. So for the left side we had negative 22. Let's see whether we'll have the same negative 22 for the right side. So we have y minus 19. So wherever we see y, we put negative 3 there, right? So this one will become negative 3 minus 19. And negative 3 minus 19 will give you negative 22. So it means that we are correct. So the left is equal to the right, right? So After solving your equation, if you want to justify your answer, if you want to test to see whether you are right, you can just replace the answer, your answer that you had, in the equation. So you fix the value in the equation and then you work your way around it and see whether the value on the left side will be the same as the value on the right side, right? So in maths, you can always justify your answer. You can always you can mark yourself. Actually, you don't really need a teacher to mark. You can mark yourself, right? So equations is one of the topics that will help you to assess whether your answer is right or wrong. So assuming we fix the -3 in the equation and then we didn't get our answer, or the value of the left side was not equal to the value on the right hand, at least it would guide us, or it would prompt us that perhaps there was a mistake that we made, right? So knowing that we've made that mistake, we can go back and correct that mistake, right? So that is just a tip I would like to give you. After solving, if you want to be sure whether you are right, just fix the value into the equation and then test your answer, right? Okay, so let's look at this example here too. So we are going to apply the rules, right? We're going to apply the rules to solve this example. So we have to solve 7x minus 4 is equal to 3x plus 16, right? So what this means is that the value of 7x minus 4 must be the same as 3x plus 16. So after solving our equation, whatever answer we get for x, when we fix it back into the equation, that is, wherever we see x, we'll put that number there. And when we do that, whatever answer we get at the left side, it must be the same as we will get for the right side. So let's solve and see what we are going to get. So we are simply going to apply the principles. So 7x minus 4 is equal to 3x plus 16. So here, since we don't have any brackets, we go straight to group like terms, right? So there is x here, there is x here. So it means that we have to group all x at one side and then group all constants or all numbers at the other side. So we are going to transpose this 3x to the left side of the equation. So we are going to have 7x. Since it is positive, when it crosses, it becomes negative. So we're going to have 7x minus 3x is equal to 16. Okay, this 16. Now this is -4, right? So in moving, it becomes positive at the right side. So we have 16 plus 4. 7x minus 3x gives us 4x. 16 plus 4 gives us 20. So we have 4x is equal to 20. Because we want to find the value of x, not 4x, we have to divide both sides by the coefficient of x, which is 4, right? So that it cancels out the 4 up here. So we'll have 4x over 4 is equal to 20 over 4. And our final answer is going to be x is equal to 5. So let's fix our 5 into the equation to see whether we are going to get the same answers for both the left side and the right side. So wherever we see x, we replace it with the number 5. So here for the left side, you're going to have 7 times 5, that is 35, minus 4. What is 35 minus 4? It is 31. Let's see whether we are going to get 31 for the right side. Okay, 3 times 5 gives us 15. 15 plus 16 is also 31. So we are correct, right? So that is the length and breadth of equations. So whatever is at the left side must be equal to whatever is at the right side. As simple as that. Okay, let's move on. Alright, let's look at linear equations involving fractions. So if you are solving linear equations and you come across fractions, how are you going to go about it? So let's take some few examples and try to understand it with them, right? So we have to solve for x if 2x minus 1 all over 5 plus 1 is equal to x all over 2, right? So whenever you have fractions, or whenever you encounter fractions and linear equations, the first thing you have to do is that you have to multiply through by the LCM. You have to multiply through by the LCM, right? So that you would get rid of all denominators, right? So we want our equation to be linear. So what we do is that we multiply each term by the LCM, right? So that the denominators will cancel out the LCM, right? So here the LCM of 5 and 2. So our two denominators here are 5 and 2. So what we are going to do is we are going to find the LCM of 5 and 2, which is 10. So we are going to multiply each term by 10, right? So we are going to have 10 times 2x minus 1 all over 5 plus 10 times 1 is equal to 10 times x over 2, right? Then we will simplify, right? So 5 goes into 10 two times. So 5 cancels itself once. It would cancel 10 twice, right? So for this expression, we are going to have 2 into bracket 2x minus 1. When you come here, you have 10 times 1, which is 10, is equal to, here 2 divides itself 1, it would go into 10 5 times. So we'll be left with 5 times x, which gives us 5x. Right. So after multiplying through by the LCM, you are going to arrive at 2 into bracket 2x minus 1 plus 10 is equal to 5x. You see, now we've gotten a linear equation, right? So we don't have any denominators again, right? So the purpose of multiplying through by the LCM is to get rid of all these denominators so that you have a linear equation, right? So the next thing is to expand the bracket, right? So in expanding the bracket, here you are going to have 2 times 2x giving us 4x, and then 2 times negative 1 giving us negative 2, right? And then we add a plus 10, everything is equal to 5x. The next thing is to group like terms. So we want to group all x at one side and then group all the constants or all the numbers at another side, right? So here what I did was I decided to take the 4x to the right side, right? So okay, before that we solve this one. So 4x minus 2 plus 10, so negative 2 plus 10 will give you positive 8. So we are going to have 4x plus 8 is equal to 5x, is equal to 5x, right? So the next thing is to group like terms. So I decided to take the 4x to the right side and maintain the 8 at the left side. So we had 8 is equal to 5x minus 4x, right? So in the end you're going to have 8 is equal to x. 5x minus 4x is x, right? Therefore our x is equal to 8, right? So it doesn't really matter if the variable is at the right hand side, right? So 8 is equal to x is the same as x is equal to 8, right? It is the same, the value is the same. Well, if you decide to bring the negative 5 to the left side, so you're going to have 4x minus 5x is equal to negative 8, right? So because this 8 will cross and become negative 8, so you're going to have negative x. Mind you, 4x minus 5x will give you negative x, right? 4 minus 5 is negative 1, so 4x minus 5x will give you negative what? Negative x. So you get negative x is equal to what? It's equal to negative 8, right? Now you have to find the value of x, not negative x. So it means that you divide both sides by what? By negative 1. You divide both sides by negative 1, and when you divide both sides by negative 1, you're going to have x is equal to negative 8 over negative 1. Now you can punch on your calculator. Negative 8 over negative 1 is equal to 8, right? So whenever you divide a negative number by another negative number, the answer becomes positive because the two negatives will cancel out, right? So negative 8 over negative 1 is what? Is positive 8, right? So you can try it on your own. You can decide to bring the negative. You can decide to bring the 5x to the left side, and then take the 8 to the right side. You get the answer that I spoke to you about. You get the same answer of 8. So it means that when you fix 8 into this equation, whatever value or whatever answer you get for the left side will be the same as the answer you get for the right side. So you can try that on your own. Okay. Alright, so let's look at another example here. So we have m minus 3 all over m plus 2 is equal to 2 over 3, and we have to solve for m, right? You have to find the value of m. So here too, we are going to see m plus 2 and 3 as our denominators, right? So the LCM becomes 3m plus 2, right? So we are going to multiply this by this. So basically with LCMs, you just multiply the denominators, right? You just multiply the denominators. Typically with LCMs, right, you just multiply the two denominators or the various denominators. That is, if one is not a factor of the other one, right? If one is not a factor of the other one, you just multiply. Or whereby you have variables as part of the denominators, you just multiply the various denominators to get your LCM. So how do you get your LCM here? You simply multiply the two denominators. So m plus 2 is one denominator, and then we have 3. So our LCM becomes 3 into bracket m plus 2. We are going to multiply both sides by what? By the LCM. So when we come to the left side, you are going to have 3 into bracket m plus 2 times this expression, right? This expression here, m minus 3 all over m plus 2 is equal to the same LCM, 3 into bracket m plus 2 times 2 over 3. Alright, so when you get here, this m plus 2 cancel out this m plus 2, leaving you with only 3. So the expression at the left side will be reduced to 3 into bracket m minus 3. When you come to the right side, this 3 down here will cancel out this 3 up here, leaving you with m plus 2. So m plus 2 will multiply 2, so giving you 2 into bracket m plus 2. Alright, so the next thing is to expand the brackets. So when you expand this bracket, you're going to have 3m minus 9 is equal to this bracket to give you 2m plus 4. And then the next thing is to group like terms. So you bring the 2m to the left side, and then you take the negative 9 to the right side. So because it is positive, when it crosses, it becomes negative. So you have 3m minus 2m is equal to 4 plus 9. So our m will give us 13, right? As simple as that. Now let me show you another way of solving this kind of question. Whenever you have one fraction being equal to another fraction, you can employ what we call the cross multiplication. The cross multiplication. Now cross multiplication simply means that you multiplying the numerator at one side of the equation by the denominator of the other side, right? So when you pick m minus 3, you're going to multiply by 3, and when you pick 2 at the right side, you're going to multiply by m plus 2 at the left side. So it means that you are going to have 3 into bracket m minus 3, and that is the same thing we had here. It's equal to 2 times m plus 2, and that is the same thing we had here, right? So you can employ cross multiplication when you have just one fraction being equal to another fraction, right? So m minus 3 all over m plus 2 is a single fraction. 2 over 3 is another single fraction. So since one fraction is equal to another fraction, you can decide to deploy or make use of the cross multiplication approach, right? So that is just an alternative way of solving this question, but in the end you should get the same answer, right? So let me give you a simple assignment. So you can pause the video and then fix 13 into wherever you see m, and find out whether we are right or wrong, right? If you check it and we are wrong, well, you just correct yourself. But I believe you know that we are right? So when you put a 13 wherever you see the expression at the left will be equal to the expression at the right. So you can verify. Find out for yourself, right?